Okay. Did I miss anything? I don't think so. Wargames, yeah. Who knows the movie? Probably the older ones. It's not about the movie. Who knows Spy versus Spy? It's also not about that. So I came up with the title. It's always when I start presentation, I come up with a title. And then I was looking for something good and evil. And I was like, that was the Spy versus Spy thing. So I created this slide deck like this. It's totally unrelated. My name is Gerrit Grunwald, as Gerrit already mentioned. I'm living in Münster, close by, and leading a Java user group there. I'm working for Azure as a developer advocate. I did a lot of JavaFX and UI stuff in the past. I ditched that a bit because I think I did everything in JavaFX that's possible. And now I'm more focusing on the JVM and all these kind of things. So, I'm a developer, and I'm not a security expert. But this session is about security, just to make you aware that I'm not the expert here, right? So I'm more like you guys. Who's a security expert here? Okay, that's good, because otherwise you can go home. No, probably more than me. So, and November 24th, 2021, this thing happened. Who was affected by that? Yeah, probably a lot of you. And that made me think, because I'm more from the 20th century. So when I started coding was in 1982. And at that time, the software landscape was totally different. So it was like, everything was self-written and closed source. There was nothing like open source, really. The source code was managed in a repository or on a local server, or maybe it was just in a folder and you copy and rename folders. That's how it worked. Everything was manually built. It was delivered on hardware like CD, DVD, floppy disk even. USB sticks. It ran on closed networks or local servers. And mostly large monolithic systems, more or less. Connected systems only in the government or banking, energy providers. These systems always have been connected, but more or less the rest was not. And we had the full control over the source code. That was the main part. And that was given, right? Everybody was like, okay, source code is ours. We know everything, every bit of it. Well, the vulnerabilities in the 20th century have been totally different from today's, so it was more or less password hacking and cracking, because everything was closed source and in closed networks. You have to find a way into these networks, which was looking at the trash, finding some snippets if someone maybe wrote down a password. Computer viruses just started, and they have been spread by floppy disks or USB sticks or stuff like that, and it was the early days of internet hacking, but time flies. And then suddenly I found myself in the 21st century, and to be honest, I never thought about security. For me, I was writing the code, I was happy with that, then I throw it over the wall, and then the ops guys, they do it, right? They do the deployment, they run it, and I don't care. So software landscape is totally different today. So we have lots of open source software everywhere. Who's using open source in production here? Probably all of you. So we have distributed source code management systems. We have automated builds by CI/CD systems. It's hosted in artifact repositories. It's running on public networks. It's accessible via browsers or APIs. And everything is connected these days. And we have a complete software supply chain today. And we don't have the full control over the source code anymore. As you said, you all use open source. That means you just get the stuff from the internet, made in Central probably, and you trust it, and you use it. And why? Because everybody does. Did you ever scan the stuff, or did you ever ask yourself when you download something, is that JDK that I download from the whatever Tamarin website, is it secure? Is it safe? Is it scanned? You just download and trust, it's fine. They scan it, it's of course they do. But you don't know. It's all about trust, right? And vulnerabilities these days are totally different. So we have the most dangerous thing is social engineering. Who knows that? It sounds like more the fancy stuff for the young guys, but we are all affected by that, because who's on social media here? Probably all of you somewhere. And it's crazy. When you look up SIM swapping, and if you never heard about it, look that up, read through it, and then ask yourself about two-factor authentication again. And then it makes you think. This is really, it's about how to take over a phone. And if someone takes over your phone, it's your identity, it's your bank accounts, everything is in there. And they have full control. And this is not something from science fiction movies. This is happening right now. People do that. So you really have to be careful with this kind of stuff. We have malware and ransomware. It's very easy to spread that, even per short message services on your phone. Everything that is connected will be hacked, and we have malicious code that is spreading. Is very easy these days. And the whole software supply chain is target of attacks. But before we start, we have to look at some definitions. Because when I started looking into that, I stumbled upon all these American acronyms. These guys are crazy with their acronyms, and I had no idea what it means. Like CWE, right? Common Weakness Enumeration. This is, so there's a lot of QR codes here. You don't have to take pictures. I can provide the slides. I don't know if you have a place where you put them for download.
Yeah, we can put them via Meetup.
Yeah, because there's lots of links in here that might be quite useful. That's a community developed list of software and hardware weakness types, and if you find issues somewhere, names an issue, then you often find a CWE ID together with this issue. And it's all on the CWE-Mitre.org website. There's all the descriptions about these things. It's not the most important one, but you will stumble upon CWE. The next thing is the NVD, the National Vulnerability Database, and that's probably the most important thing to know. So that's a US government repository of standards-based vulnerability management, blah, blah, blah. You can read it on your own. So the important part is there is a central place in the US, but it's used globally, where they store all the information about vulnerabilities. They collect them in this NVD, and it's publicly accessible. And there's an API, you can get a free key to that, and then you can access the NVD, and you can get data from there. And what kind of data, we will take a look at that, because this is the so-called CVEs. That's the common vulnerability and exposures. And the mission of that program is to identify, define, catalog publicly disclosed cybersecurity vulnerabilities. So this is, in principle, that's the entries in the NVD. That's the CVEs. And people talk about CVEs when they talk about security issues. They have something like CVE, and then there comes a number. And the security guys know all these numbers by heart. We know, oh, there's log4shell, but for them it's different. So for us it's this. For security guys, it's CVE 2021, whatever number, right? So, but they know exactly, oh, this is log4shell. Log4shell is just for us, so that we also can remember. If you find something like that, you can look that up in the NVD database, right? Okay. And you will find something like this. This is the entry for log4shell. It's an older copy. You don't have to read through it. The important part is that they tell you which versions have been affected, and then also the vulnerability itself. So they explain the vulnerability to you so that you know how you can hack it. Then the description of the whole thing, and that it's quite some description. So, but it's interesting. If you have no idea what it is, you can look everything up in the NVD. So that's quite useful. And as I said, if you have never heard about it, who has never heard about CVEs? Yeah. Probably since log4shell, everybody heard about it. It was in the Tagesschau in Germany, that was the moment when I realized, okay, I should take a look at security stuff, because if it's in the Tagesschau in Germany, then it means it's serious, right? This is a serious problem. And then now we have the database, we have the issues number tracking system, like the CVEs, and then we need a scoring system for that, because we need to make sure, okay, if we have a CVE, is it a high score, is it very critical, or is it low score, means not critical? That's the CVSS, so the Common Vulnerability Severity Score. It always comes with a CVE. And to make it more complex, there's not only one, there are two different standards. And the older one is this one, CVSS 2.0, and we just have three categories, low, medium, high. And you see it starts with 0 to 3.9 and so on. And they figured out that this is not really a good way of doing it, because even if it's 0, it's low. That means it will pop up as a low severity. And that's not really a very clever move. So they came up with the idea we have to change it, and they changed it to this one, which is CVE 3.1. And in November last year, there was CVSS 4.0, but it's the same scheme. It's more than this score. CVSS is tons of information for security people. This is just the stuff that we need to know, the scoring system behind it. And now you see that 0 is now none, so there's no vulnerability here. And then it starts with 0.1, and they did 4 categories. Now we also have critical, right? And why I mentioned both of them, it's not a replacement really. Even in today's issues, you will find the CVSS 2.0 and the 3.1 scoring, both. In the older ones, they only have 2.0, and then probably at some point in the future, they will get rid of the 2.0 scoring and only use this one, but you will find both at the moment. And the important part is that you need to know which scoring system was used. When you get just a score, it doesn't really help you here. So if we take a look at Log4Shell, then it was the old scoring was 9.3, which was also high. In the new one, it's 10.0. So that's critical. That's the most critical vulnerability score that you can get was Log4Shell. That was a really severe issue. Okay, so now that we have this one done, the question is Java secure? Did you ever ask yourself, I mean, I asked that already. If you download some JDKs, where did you get it from? From websites? SDK man, something like that. Did you ever ask yourself if the JDK itself was scanned? Who did scan it? You scanned it.
No, but not me, but using it all, because there are page values.
Yeah, it's really, but mostly people don't really think about it. They just download it, install, and run it, right? Without really thinking, oh, is it secure? I don't know. The same goes for stuff that you download from Maven Central. You just add a dependency because you need the dependency. And then you run it. Oh, it's on Maven Central, cool. Oh, I just used the latest version, it's fine. But you never really check if this is scanned, right? You just use it. You just trust that it's secure. So first of all, there's the Open Vulnerability Group, OpenJDK Vulnerability Group. And it's a group of a private forum of trusted members of the OpenJDK community. And these people receive and review reports of vulnerabilities. And you can't really, even if you're a security expert, you can't just go there and say, oh, I would like to be part of it. So they pick people that become part of this group. And so it's a very, very specific group of people of the OpenJDK community. And then they collaborate on fixing the issues. They don't really fix the issues themselves, but they figure out strategies and delegate it to people. So they coordinate the releases of such fixes, and they maintain the list of CVEs that you will find when you download a JDK. Most of the times you will get a list of CVEs that have been fixed in this JDK version. Did you know that? Did you ever saw that? I will show it to you. There's a list. It comes with every JDK update. And they also track CVEs by components. We have a modular JDK now. That means it's possible that an issue, a CVE, for example, just attacks one module in the JDK. If you don't use that module, you're not affected. So this is something that makes it important that you track CVEs by components, not only, oh, this JDK is vulnerable to that CVE. It doesn't really help you a lot if you have a modular JDK, right? Because maybe you don't really use it, these modules. And they discuss OpenJDK security-related issues. And like I said, they do not actively test OpenJDK source code. And they come up with this OpenJDK vulnerability advisories. That's the stuff that comes with the JDKs. And it's 4 times a year they will be published. They're describing severities, areas, and affected versions. And this is an example how it looks like. That was from 16th of January. And then you see something like this. You see a list of the CVE IDs, and these are links. If you click on it, it will bring you to the NVD. You can read it up there. And it will tell you which component was affected. And then this is the CVE score. You see it's 3.1, so the newer one. And then it tells you which JDK versions have been affected by the change. And this comes with every JDK update. You can get these advisories and then you can look it up. So that's quite interesting. So if you're not sure if you are affected by some CVEs, you can look it up in these advisories. And that leads me to the Java release cycle, because they changed a lot. I mean, this was the old one. And you see from 6 to 7, it was 4.5 years. And then from 7 to 8, that was 3 years. And that was the first so-called LTS release, which Oracle taught us are not existing anymore, LTS releases, officially. But still there are versions that have longer support than others, so it's a long-term support versions and which is LTS releases. So they changed that with JDK 9, and you see now this is the new release cycle, where we have every 6 months we have releases now. You might ask yourself, well, how is that related to security, this release cycle, right? Well, it's pretty easy. This is the old one, or the end of it, and you see this is the number of features per release, right? And with the new cycle, it's just a number of features per release. And you can imagine less features per release means less potential vulnerabilities per release. It's way easier to test that stuff, because if you have 56 or 91 new features that you have to test and make sure that everything is secure, that's a lot more work to do, and the probability that you have issues in there are way higher. So this is the reason why if you have, for example, just 5 or 7 new features in a release, it's a good thing, because it's way easier to test and make sure that it's secure. Java updates, yeah, this is an interesting topic, because most of the people have no idea. Who knows a CPU update? Nobody. The critical patch update. It's updates of the JDK and JRE, which only contains fixes for vulnerabilities and critical issues. And that's it. No new features. All right? Then we have PSU updates. Does someone know what that is? This is the stuff that you download if you download the JDK update from the internet. That's a patch set update. This is the publicly available updates for everyone. This is based on the CPU, but they also add non-critical fixes, and they also add tiny features. This is nothing like Loom or something like that, these features. This is tiny stuff where I think, oh, we can improve this one, just do it with the next update, stuff like that. Right? And if you add new features, then you add the possibility for new vulnerabilities, right? How does it work? So if we take a look at 1702, that came out in January, 3 years ago, I think. And in the upper part we see the PSU, right, that contains the CPU, and in the lower part it's only the CPU updates. So that was January. The next update came out in April. That's the yearly cadence now. And you see now that the upper part contains fixes and features that getting into 1703, where the 1703 CPU only gets vulnerability fixes from this one. No new features. That means the CPU is always 6 months behind the last PSU, and it's based on the last PSU. You might ask, what's the reason for that? That's another 6 months where you can test the new features that came with this one and fix them, and only provide security fixes, nothing more. The CPU updates are not for free, so you can't get them for free. That's the reason why you don't know them probably. You only get them if you have a support contract with either Oracle, Bellsoft, or Azure. That's the only 3 companies who offer these CPU updates. Because it's a lot more effort to do that. We have to keep separate branches with only doing the security fixes and provide them. So that's the reason why also for Oracle and for Bellsoft you have to pay for this kind of things. But if you really run mission critical stuff, then, and I will give you an example why that is, could be important. And then it goes on. July is the next one, and then October the next one. And you see it's always 6 months. It's always based on the last PSU is the CPU. Right? So that's the idea here. Why does it matter? Well, there was with JDK 8 update 252 introduced a change. That's one of these little features And that prevented Hadoop cluster and Solr from running. If you installed that, you couldn't run Solr anymore. And that was an official update from the website from Oracle. You just download it, install it, and suddenly, bam, nothing works. If you use the 251, that's the CPU, at that time they have been for free. That was based on this older one, on the older PSU, right? Before that one. And this only had the security fixes, and that worked. That didn't have the new features that came with the 252. This is just one example, and there are a couple of them. So this stuff happens, but it's not really in the press because it only affects the CPU updates, and because they are not available for free, people don't care. Because if you write an article in the Java magazine, then nobody knows this CPU update, what's that? Never heard of it, right? But this is stuff that happens, so that's why that's the reason why we do that. Because we have customers, especially in banking, insurance companies, they have really mission critical things running in their production systems, and they have to make sure that this is always secure and runs, right? They can't really risk stopping the whole system. Some companies, if you have mid-range companies, they say, we don't care, we just stick to the old one, right, for the next 6 months. Yeah, you can do, but I will give you a reason why this is not a good idea. Because let's take a look at the impact if we don't do updates. Right? Let's say we start from JDK 17 and we go to 17.010. So we start with 17. That was September 2021. In October, this is just 1 month later, there have been already 8 CVEs in the JDK code. So that means if you stick to 17, you're already open for 8.1. Okay. This is medium stuff. This is not really critical. This is kind of critical. Okay. That was just 1 month after. And then 17.02, 15 new CVEs. This is always on top, right? On top of the ones that we already added. And then it goes on. And you see it's already a high one, 17.03. And then you see it's a lot. I know it was a little bit less. But it's a lot of issues that come with each update. That means if you now today stick to 17 general release, 17.0, then these are all the CVEs that you are open for, which could be really critical if you run a bank. Right? So you would like to make sure that you're always on the latest version, because if your production system is vulnerable for these kind of CVEs, then probably you won't have any customers anymore. Right? So that means this is 61 issues that you have in your JDK if you run on 17 only. So the first advice, always update your JDKs everywhere, on your development systems, on your production systems, always. It's for free, do it. Really, this is not a joke. And as I said, we have customers where it's mandatory, they have to use CPU updates. So they can't even choose, and there's a reason for that. So then there are people that say, if it ain't broke, don't fix it. It works, it's fine. But I say, if it ain't broke, at least keep it up to date, right? This is not really a big deal. It's easy, it's free, and you can do it more or less automatically. It's not really hard. The next thing is modular runtime images. Who's using JLink? Nobody. Who knows JLink? Ha! This is cool. At least some people heard of it. So we have the JPMS, and that's the Java Platform Module System that came with JDK 9, right? Just as a reminder, we have 21 already, right? So 22 is already out, right? So the module system came with JDK 9, and the idea is if we reduce the number of modules that is in my runtime environment, I reduce the number of security issues or risks for security issues, right? As I said, we have CVEs that only attack specific parts of the JDK. Let's say the CORBA module. If you don't have the CORBA module, if you don't use it, you are not affected. But if you just use the standard JRE, then, for example, the CORBA module might be in there. Not anymore, but I think 17 it died. But these kind of things, you're always affected if you download the standard JRE because that contains all the stuff that's needed to run. Is someone running a JDK in production here? Okay, that's good, because I always ask that, and people do that, really. And then they tell me, yeah, but I need that for debugging. That's bullshit, right? And if you have the JDK, then you have everything there. That's a lot. We will see that. So JLink makes it possible to strip down the JDK, or let's say the JRE, to your own application. So what it does is, there's a tool called JDEPS. And what you can do is, it's for dependencies. You can run it on your, let's say you have a fat jar of your application. You can run JDEPS on that fat jar, and it will tell you all the modules that you use. And then you can use JLink to create a JRE just with these modules, because that's all you need. And if you have a is someone running microservices here by any chance? So that means you probably have microservices that just use a specific part of the JDK modules. You don't need the whole bunch of modules. So it's really a good idea to create your own runtimes and strip the JRE down and reduce the risk for securities, right? That's the idea. Hackers cannot attack what isn't there, right? That's the thing. And by the way, your application doesn't need to be modular. We just talk about the JDK. It's not about your application. It can be just a standard class path application as it was before. The JDK can be stripped down. To give you an idea, that's JDK 2101. That's all the modules in there, right? That's 69 modules. It's 339 megabytes. So if someone runs a JDK in production, that means 339 megabytes. Just maybe for run a microservice, that's maybe 60 kilobytes or something, right? So this is, sometimes you have to think about it. If you use a JRE, then this is the number of modules. Still 50 modules. Still 150 megabytes. Now, the example that I use here, that's a push notification server that I wrote for my own application. And I used the JLink to create my own JRE. And that was the result. That have been the modules that my push notification server really needed to run. And that was 11 modules, right? And that was 48 megabytes. And if we talk about footprint for deployment, then you really should think about it, because 48 megabytes or 150 megabytes, that's a huge difference, right? So you really should take a look at JLink and modular JDKs, because it really makes sense to strip down the JREs. To give you an idea, the circles really represent the size. This is the difference in size and the modules if you use JLink builds, in this case, I have to say. Depends on your service that you build. But usually you don't need the 50 modules that comes with the JRE, right? It's not really needed. Take a look at JLink and JDEPS. There are lots of descriptions on the internet how to use it. It's not really hard. That leads me to software supply chain. I came up with this diagram, which looks very similar to all the others that you will find on the web. It starts with us, developers. We use a central repository where we get all our code from. Usually it's Maven Central. Then we have our own repositories where we submit the code to. We have CI/CD build pipelines, and then these also drag in other dependencies from the central repository. We build our own containers here, then push the stuff in some artifact repositories that can go back to the central repository, and then there's also a production where we deploy the stuff to. So the points where vulnerabilities can or are open or in this supply chain will be attacked by vulnerabilities are all these red triangles. Sometimes sounds really strange. I have descriptions for all of these points, but it will lead too far. It's really interesting how to say that. The hackers are really smart in figuring out how to hack systems like CI/CD build systems. I never thought that there is a way into this build system to change code before building it. But there are even artifact repositories can be hacked, and container registrations and all these things. It's really crazy. People hack everything. So you really have to make sure that you are secure in the whole software supply chain. So I have some facts that I found on the internet. There is a Sonatype State of the Software Supply Chain report. I can really recommend to take a look at that because it's most of it is free, and they will give you some interesting numbers for you. These guys run Maven Central, so they have a lot of source code that they can scan. And they figured out that, and this is from the last year in March, so it's a little bit outdated already. They figured out that in the last 3 years, the increase of vulnerabilities of attacks was 742%, that they could measure that, which is a lot. And this is from the NVD database. They also have some statistics about vulnerabilities and with the score, like low, medium, high, it's the old scoring system here. And they found out in 2021, they saw 20,142 new unique bugs and security vulnerabilities. You see this jump in 2017, I think it is. Maybe they changed in the counting system something, I don't know. But this is a huge jump there. I'm not sure if there was something different before, but these are big numbers. So that means this is a serious problem, the whole hacking thing. And, oh yeah, this is an interesting one. I talked to Christian Grobmeier, who's one of the maintainers of Log4j. And he told me, and that was last year, October, that you see even, like how many, 21 months, that was in October, after this issue has been fixed, 20% of all downloads still download the old version, the vulnerable version. It's just because people are lazy. They hard-coded some version numbers in some scripts and then they will be downloaded forever. They forgot about to update whatever build scripts where they have hard-coded version numbers, or I don't know. It's really crazy that if you think about it, that 20% of all the downloads of Log4j still download the old vulnerable version, right? And he was also, and the number had been higher last year in March. It was, I think, 34% or something. So it gets lower, but it's still high. And you would think everybody learned from that. Nobody will download the old versions. And people said, why are you still offering the old versions? And he said, because we don't know who depends on that. We can't just take it away because maybe we break some systems, they still use the old system. We don't know. So they keep, and I think it's a good idea to keep all the versions, even the vulnerable ones, available. People should just fix their systems. Right? Then this is another thing from Sonatype. They figure out that 6 out of 7 project vulnerabilities came from transitive dependencies. So that means your project, you have some dependencies in your Maven file, that's fine. Then these dependencies drag in other dependencies that you don't know of, and so on and so on. And you get that tree, and at some point there can be vulnerable dependencies and you have no idea about it because in your Maven file looks good, right? So, but you just, from this file, you can't really tell if all your dependency tree is really secure. And then that's another report that's from Synopsys, that's also a security-based company. So they found out that at least one vulnerability in 84% of their code bases that they scan, they found at least one, and in 48% also high-risk vulnerabilities, which is also a lot. That means half of their code base contained at least high-risk vulnerabilities, which is crazy. I mean, if you think about it, who's using a security scanner here? That's very good. Let me tell you that this is not the typical answer. So at the conferences, and some people say, yeah, I heard of it. So another thing that they figured out is that open source software was used in 96% of all the code bases that they scanned, and 76% of the code bases was itself open source, right? And that leads me to open source in general, because this is a good thing. But did you ever read that? I mean, really read it and understand it? You don't have to read now. I will just highlight the important parts. There is provided as is, right? Without warranty of any kind. In no event shall the authors, copyright holders be liable for any claim, damages, or other liabilities. That's what it says. If you understand that, then you should know what it means. Because it means I owe you nothing. Right? That's exactly what it means. I write the code, here you go, now it's up to you, right? But people don't see it like this, right? So this is usually how it works. You probably know that. And when I did the presentation one of the first times, I was in Nebraska, and I didn't realize that it's some random guy in Nebraska. Everybody was laughing over there. What's so funny? And say, okay, got it. So you have to keep in mind when you use open source. First of all, open source maintainers are not suppliers, right? So you don't have any business relationship with them. Nobody from you signed a contract with Dirk Grotmeyer for Log4j, for using it, right? So you just use it for free. So that means if you use their code, it's up to you to make sure that it's secure. It's not their fault, it's your fault if it breaks your system. Right? So and this is what people sometimes get wrong, right? Say, oh yeah, well, how can it happen? They should have scanned it. Well, they probably did, but I mean, it's what the license says. And if people read it, they should understand, okay, it's up to me and not up to them. And this is something that people sometimes have to learn. Open source is a good thing, but you are also involved, even if you just use it. You have to make sure that it's secure and you have to scan it at least. And then you have to report back if you have security issues. So what can we do? Well, shift left is one of the approaches. Who knows what that is? It's pretty simple. This is the software supply chain. And as I mentioned before, for me, software development was like, I write the code, I throw it over the wall, and then the ops guys do the rest, right? We are on the left side of this diagram. And here's the right side with all the deployment. Dev is left, ops is right. Shift left means that the security awareness should shift to the left side of the diagram. We should be more aware about security. We should, when we code something, we should think about security. This is the idea behind shift left. So if we take a look at DevOps, which in the meantime becomes DevSecOps because security is so important, then we see this is this DevOps loop which started planning, coding, building, then releasing, which is the dev side, and then there's deployment, operating, monitoring, and then back to planning, which is the ops side. Where's security in this diagram? It's everywhere, right? Security belongs to all of these parts. It's not one left or right thing. So that's the whole shift left thing. We should also think about security when we write our code, and there are tools, and I will show you some that can help us with that. So shift left, yes, but also validate right. And I will tell you what I mean with that. So first of all, we have to update your JDK. I told you that. So there's SDKman. Who uses SDKman? Okay. And the rest is probably on Windows. How can I interpret that? So it's command line only. Supports many JDKs. It's for Linux and Mac OS. And it downloads and installs and can even update JDKs. And other stuff too. Then there's JDKmon. Yeah, it's my tool. I was so lazy, and I was really I hated it when I always have to look up, is there a new update from the JDK, because I can't really keep the dates in my mind. So I wrote a tool that just checks my disk for JDKs and then tells me, there's a new version, and let me download the version. So in principle, it's very similar to SDKman. And they both use the same source, because I wrote the Disco API and SDKman used the Disco API, and I use also the Disco API. So Disco API is a discovery API that gets all the downloads of all the JDKs, and I use the same thing. For me, it was also a test if the Disco API works correctly. So it supports all JDKs, including GraalVM and also JavaFX SDKs. It can download it, but you have to install it. And this is a taskbar application that sits in your taskbar and then tells you if there is something that it can be updated, then it shows you that. It's a Java application. And it also shows you CVEs in the JDKs that you have installed. This is how it looks like. It's just, if you click on the icon, it will open the window, tells you all the JDKs that you have installed, and then it tells you the version numbers. If there's a new one, you see the new one, you can download the different formats. And if there's something like this here, then it means for this JDK, there is a vulnerability in the NVD. If you click on that thing, it will open up and it will show you these things, and you can click on the links and it will open it in the NVD database for you. You can read it up. It shows you the severity score, and this is, it tells you also this is 3.1. And like I said, this is just a tool that I wrote because I'm lazy. And I don't use SDK-man, by the way. So because I need something UI made. I work visual. The other thing you can use is static code analysis. You probably heard about find bugs. There's a successor to that. I think even another one. So yeah, exactly. So this is the most known tool. It's usually part of a code review or white box testing, and you can identify vulnerabilities already in your source code, right? So this is exactly for us. If we write code, this kind of analysis can check your code and can tell you, by the way, there is something you should really fix because it's a vulnerability probably. At the implementation phase, and that makes it very inexpensive because you can directly change it before it even goes into the repository sometimes. So there are standalone tools and there are IDE plugins, and these are all the different static code analysis tools you can find. There are free ones, there are ones you have to pay for, and this is a list that comes from the NVD. They give you, it's not really the list. They just tell you this is a list of static vulnerability scanners that you can use. There's no scoring in here, so it's just one list. So find security bugs, that's the new one, and it's free of charge. Extend spot bugs. Spot bugs is the successor to find bugs. 400 plus bug patterns. It's a plugin for your IDE, and what it does is, if you have, for example, IntelliJ, there's a plugin for that, and then it will tell you directly in the code. If you scan it, it will tell you with little bubbles, or I think it's attention signs or something. And then you can click on it and it will tell you, this is the problem, here's how to fix it. Then there are vulnerability scanners. That's a different story. The other one was static code analysis. It's really just your source code. These things can do way more. So they can detect vulnerabilities, and they use databases or probing patterns to do that. And they monitor misconfigurations and coding flaws. So I'm just showing you the stuff for the development, not really because they can do way more. They help using only artifacts from reliable sources, so they can make sure that you download that your dependencies coming from reliable sources, and not that someone hosted some jar on his website and you download it from there. Or maybe you have a transitive dependency that downloads it from there, right? You don't know. They help using only latest secure version because they know this version is secure, this one not, so you better stick to this because that's the secure one. They can monitor appearance of new packages, so if there is a new version available from the dependency, they can tell you, here there's a new version, would you like to update? They can even update it automatically, the dependencies, exactly. And the vulnerability scanners usually work here, right? They can scan and fix your source code, they can even work and monitor on the repositories, on CI/CD. They can scan artifact repositories, and some of them can work in production, but really just a few. And most of them use agents to do that. Does everybody know what a Java agent is? I will explain it shortly. This is the JVM or black box, and it has different parts: class loader subsystem, JVM memory execution engine. And the JVM is quite cool because it comes with the API. It's so-called instrumentation API. And to that instrumentation API, you can attach an agent. It's called Java agent. It's a Java program that can talk to this API, and then you can talk to the JVM at runtime. That's the idea. So what it does, it hooks up to the class loader subsystem, and then it establishes here a callback. So, and that means every time a class is loaded, the JVM will tell the agent, I loaded the class. And then the agent can do something with that information. Usually they look up, oh, where's this class belonging to? Oh, it belongs to this library. Where does it come from? Okay, from there. Is it vulnerable? Okay, it is or it is not. Something like that, with every class loaded. It comes really with an overhead of at least 10% performance. And then now I have to ask you, who's running security scanning in production here? Nobody, because you trust your CI/CD systems, right? You say, I have something in CI/CD and it's secure. But we all know that Java is dynamic, right? We know that we can load code at runtime. Because we have a JIT compiler, we can do that. Even at runtime, we can inject code in the running program, and then it's not scanned anymore. Or another example, you scan something in CI/CD, and that's the last deployment. It was secure when you deployed it, and now in the meantime, maybe 1 hour later, there was an issue. What's then? Then your vulnerable code is running in production, and the next time when you do deployment, then you get the secure code. That's how it works. But there is time in production where it runs probably unsecure if you don't run production scanning, right? That's the problem without doing production scanning. And most of the times people don't do it because it has a performance drop here. 10%, and that means you have to pay for 10% performance to get the same performance as without the scanning. And people don't want to pay. That's the reason why it's not really used. Vulnerability scanners, again, there are different ones. We also have one. There are free versions, there are paid versions. We will take a short look at some of them. Sneak, does someone know Sneak? Oh, that's cool. It's free and paid version available, 9+ languages supported. They run a developer-first approach, so they live the shift-left thing. This is made for us, and you can feel it if you use it. It's really nice to use. It's a standalone tool, but they also have plugins for the IDE. And I only show you, and they have CI/CD integration, but that's where they stop. They don't provide production scanning because they know it always comes with the overhead and they can't sell it, right? So this is how it looks like. This is now for JavaScript because they support all. It's not important. The important part is that they can tell you where's the problem and what is the problem, right? It's similar to the static code analysis, but this can do way more than static code analysis. That's nice. There's SonarQube. Someone using SonarQube? Yeah. That's, again, the guys who run Maven Central. Again, free and paid version, 30+ languages. They have lots of analysis rules, and they're standalone, and they also have a plugin, and they also only have CI/CD. They stop there for the same reason. I mean, I talked to the people, and they told me, no, we don't do it because we have this overhead when we run it in production, and then people won't buy it, right? And this is, you don't really have to read it. It's again, where's the problem, what is the problem, and then why. They give you even more information on this whole problematic that you have in your code, which is good. And then, we also have one, I mentioned that already. And why I mentioned that is, we only run in production. And we only run Java. And the idea was, we saw the problem that nobody's using security scanning in production because of these performance issues, and we thought if the JVM itself could help us here, then we won't have the overhead, right? Because it's JVM only, so that everything that runs on the JVM can be scanned, and it has fewer false positives. I can explain you why. And there's no Java agent here, because we implemented it in the JVM itself. And we have something which is called Intelligence Cloud, and that's part of it. It also has stuff like code inventory, because what we do in principle, it's quite easy. You have the JVM. I showed you the class loading subsystem. That means the JVM knows already the class that it loads, right? So because it loads it. Now what we did is we created a little program which is called forwarder that can you install in your infrastructure somewhere, and then the JVM, when it loads classes, it just tells the forwarder from time to time, this is the stuff that I loaded. And that's all. And that there's not more or less no overhead. It's below 1% because we just have to tell the forwarder what we loaded. That's all. And then the forwarder does the heavy lifting and connects to the database and checks all the vulnerabilities and then gives you a report. That's the idea behind it. And then we also don't have any standalone version or something or plugins. This is just the web interface that we can give you. And we also have an API because this is mainly made as an extension to the other scanners. So we are not concurrent to them, so it's really, we just have an additional value here. And we can also tell you where's the problem and if it's vulnerable. And now the difference that we have is we can tell you if you use it. And that's what nobody else can tell you, because at runtime we can tell you, yes, you have a dependency on log4j in one of your transitive dependencies, but you never load the classes. So you're still secure, right? And the others can't tell you that, except you use agents. They can do the same, but that comes with an overhead. So that's the difference here. So a secure software supply chain can look like this. So you have third-party libraries, or third-party software even. So we have been at Kafka Summit in London last year. And that means, is someone using Kafka here? Okay, but you're developers. There are also Kafka users, and they come to the Kafka Summit. And then we had a booth, and the people came to us and they asked us, what are you doing? Because we have some spaceships on our booth, they said, do you use spaceships or something? And now we do Java. Well, this is a Kafka conference. We say, yeah, we know, because Kafka is running on Java. Really? Oh, they didn't know. So then we explained to them, because they use Kafka, and Kafka comes often bundled with JVMs, or runs on JVMs. And they have no idea if this stuff is secure or not, because they just use it. So that was the reason why we have been there, to explain production scanning and these kind of things. So what we recommend is use code scanners. There are others like Poverty and Contrast in development, and also CI/CD. And there is also one for container scanning, which is quite good. And then you can use Azure vulnerability detection just for production, if you like, right? You don't have to, but this is something how you can make the supply chain more or less secure. And the scanners can really work on all these things, also on the repositories and artifact repositories. I just didn't mention them all. Is someone using Black Duck here? Okay, interesting. So that means this is shift left, right? And that's what I mean with validate right, because you trust the CI/CD scans, but you really have no idea what's really running in production at the moment. It can be insecure, but if you do production scanning, whatever you use, you can validate that the CI/CD system is correct with the scanning. That's what we mean with validate right. So takeaway, follow an automated patch schedule. So that means we saw it's January, June, and so on. We have this 4 times a year, April, September, and June, July. We have this the updates. So you should follow this patch schedule by updating your production systems and your development systems. And you should automate application packaging with JLink. Really take a look at it. You can really save space for deployment, and it's more secure because you can reduce the number of modules that are in your runtime. And by the way, JREs, since JDK 9, JREs are not really officially supported anymore. This is just goodwill from the vendors because everybody was used to JREs. But there is something written where it says from JDK 9 on, you should use JLink, but nobody does. So people provide JREs still, but there's not really the need for it. So we could stop it and it would be fine. Even Oracle could do that. Watch for CVEs and libraries, which is really important. Use vulnerability scanners if you don't do, but I saw lots of you already use that. So do you need to be a security expert? No, but you need to be aware, right? This is the main takeaway. Because people, I wasn't aware about security, but now I am. And with that, stay secure. And if you have questions, now is the time. And I need the paper back for the refer. Yeah, questions, yes.
The production scanner they're using GFR events?
Mm-hmm.
Yes?
Mm-mm.
No?
Well, if we use them.
Yes.
No.
Could you repeat the question for the recording?
Okay, sorry. For the recording. There's the recording.
Yeah.
If we use JFR events for the scanning, for the triggering of the... No, we don't do that. So that's Java Flight Recorder events. Now what we do is, because we implemented it in the JVM itself, we don't need Flight Recorder or something. So the JVM, the class loading subsystem, just knows when it loads classes. So we can just trigger directly from the JVM the forwarder and then tell them.
Okay, so it's just you also JDK.
Yes, it's
Okay.
we're also working on a agent that should be, but the main target is the agent should be around 1 to 2% overhead only. So because we saw the others are always more than 10%, sometimes even 30% performance. And the goal for us is if we make a agent which then will work with all other JDKs, then it should have only an overhead of at least maybe 1 or maybe 2%, but that's it. So it's not done yet, but it will come.
Okay, thank you.
Any other question? There was another one, yeah.
Yeah, also about the Azul vulnerability scanner, is it shipped with Azul JDK?
Yeah, so the question is if the Azul vulnerability scanner is shipped with the Azul JDK. It is, we have different JDKs, and Zulu is the standard one, which is free. So it's the same as Tamarin. So we all build from OpenJDK, and you can use it in production. If you then sign a support contract, you get the vulnerability detection. That's how it works at the moment. I'm not sure if that will change, so because we have this intelligence cloud thing. If you can just buy that, I don't know. Maybe you know better. But because I don't really know how we sell this stuff. I just know what we have as products. It's at the moment it's changing because we now not only have the security scanning, because some of our customers said if you know all the classes that you load, you probably also know the classes that you don't load. And we said, yes, we do. Well, this would be very interesting for us. So what we now have, we have inventory, so we can tell you if you run the JVM or JVM with your code, we can tell you, for example, after 6 months, you know what? This code you never touched in your code base in 6 months. You probably can just get rid of it. You can remove it because it was never called, right? And this is not for small projects, but if you work in a bank or insurance companies or other big companies, they have code bases that are really old, and people come and go, and you know how it is when, oh, we have a new release. Oh, what is with this code? I have no idea. We better maintain it just to make sure. You never know. Right? So this is often how it works, right? So and then the code base, it grows and grows, and people don't throw it. No, don't touch it. It works, but we don't know. Maybe someone's using, but we can tell you if you really use it. But you have to run it for some time to make sure that really a lot of code was touched. But then we can tell you, okay, this code was never touched in whatever 6 months or 2 months or something, and then you can make the decision. Okay, we can get rid of this part and can remove it. This is also part of this intelligence cloud thing. But I'm not sure if we offer this as a package. Maybe it's, I don't know. But it comes with the JDK. You don't have to download a specific JDK. You just get a key with the forwarder, and then you can register that at the JVM. And then, so the JVM comes already with the
But
feature.
it's a paid feature right now.
It's what?
It's a paid feature. So
Yes, it's a paid feature. Yeah,
Thanks.
it's not for free. But we will have with the new version, it's probably coming out in May, I think. That's the plan. And then we have something where you can even try it for free. Let's say you can run it for a month, and then you can try by yourself if it works for you or not. And then after a month you have to pay, or you can just say, no, I don't want to have it. So, but at the moment it's not, because the cloud instances are so expensive that we needed to find a way to make it cheaper, because everything's running in the cloud there. Any other question? Yes.
Yeah, in this JLink pictures, we saw that the Java runtime also gets way smaller if we use it. So that would then also affect our image sizes, and then also we would have a good benefit also on the performance side, right?
So the question was of the JLink, if the JLink builds also have an impact on the performance side. So not really.
So more like memory performance.
Yes, the benefit is that the deployment size is way smaller, right? You saw in my example it was just a third of the JRE, and usually I guess all of you use a JRE for deployment. Yes, so if you use JLink, you can really strip it down. So, and you do that for every service, right? Every service comes, instead of you use a base image, you just create your own base images, right? You just provide your own JLink build, which is in principle a custom JRE, tailored to your application, only contains the modules that you need. That means the footprint is way smaller, makes the deployment faster, right? And the memory, because it's not really loaded, it's not really it doesn't have really an impact on your memory consumption at runtime. It's just the space that you need on your hard drive. It's way smaller, and also the size that you have to deploy, and that is also a difference, right? It makes a difference. But that's it, yeah. No, not really on performance. Also not on memory performance. Because the modules, it's not like if you use a JDK, that doesn't mean all the modules are loaded in the memory all the time. Right, so this depends. Other questions? Yes.
Is there something like jailing, but for my transitive dependencies as well? Because I could imagine that sometimes you have like lots of transitive dependencies on your class path, and there are some of these might only be used in certain scenarios. And is there something that I could just maybe drop this from my?
Oh, that's a good question. You mean to really strip down the amount of dependencies because you maybe don't need it really? Not sure. I mean, this is the drawback when using Java. If you just need one class of a library, you always get the full library, right? Because it's in there. And you can even have multiple versions of the same library in one project, which happens a lot, right? If one dependency uses log4j whatever 1.x and the other one uses 1.x plus 1, then you have both dependencies, right? Because both libraries need a different version. And there are tools, I think it's this, isn't it this SBOM thing? The software bills of materials. Sneak is working on something like that, where they can scan through this SBOM and can tell you exactly what kind of stuff you have in your dependencies. And I know that Sonatype also has something. I think Sonatype even have a product. Not sure how the name is, but I saw that at DevNexus last year. So they have something where they can tell you all this, but I'm not sure if you can strip it down.
Wouldn't using Grunwald just automatically shake off all the unnecessary things?
GraalVM in principle, first of all, no, because it's a JVM. It's the same. So
on the dependency level. So all the classes that
only if you use native image.
Yeah,
Exactly. Yes, if you use native image, and then it goes even one step further, because if you, let's say you have a library like, I don't know, whatever library, and in this library you use just one class, then the GraalVM native image just contains the one class. Yeah, that's the difference in the native image, exactly.
Are there plugins or tools that help with creating a new base image with JLink? For example, like you have, what's the name? There are plugins that create a complete Docker image based on your base image.
Mm-hmm.
Is there something that has an additional step to generate a new base image?
Okay, the question is if there are some tools that help with creating base images when you're using JLink, right? Correct?
Yeah, to create a Docker image container.
So in principle, it's not really hard, because you can use whatever base image you use with the operating system. The JLink images, I also have a script for this JDK mon that I use. There I create this as using JLink, and this is a script. You run all the stuff in one shell script where it creates the JRE for you, and then you just have the JRE. You can just copy it on your image. It's like copying so it's not really different from copying a jar file into the image with an existing JDK or JRE. You just also copy the JRE to that image. So it's not really a big deal. So you don't need a specific step, because if you create Docker images now, there's one step where you create the jar and then you copy the jar to the image, and this is just an additional copying of the JRE into that image. That's all. Because in the Docker image you don't really need to set all these paths, and you need to set Java home, but this is not really a big deal. But there's not a specific tool just for JLink. It's mainly.
I wanted to know if it's like something I can use plugin and just deal with it, because it's probably so easy to integrate.
That would be maybe there is something. I never really looked for that, because I created scripts because not sure if there is something to create Docker images directly from a plugin.
So maybe something like JIT.
Yeah,
Yeah.
Is JIT doing this already? Maybe, I don't know.
Yeah, it could. If you just write the script into the JIT, right? Because
Yeah.
you first need to build the jar to know what dependencies or what modules of the
Yeah.
JRE you are using.
Exactly.
Then you just build the new layer of JRE, and then you pack
In principle, that's pretty simple. It's
Yeah.
really so. Like I said, in the JDK mon, if you look it up on GitHub, then you will see there are 3 scripts for Linux, Mac, and Windows. And they do exactly that. They build the jar, they run JDEPs, run then JLink, create and then you have just one JRE and you just copy it over. This is just one additional folder that you have to copy to your image, that's all. So if there are tools like Jib, then it should be possible to just inject the script somewhere in there and then also copy the result into the Docker container. But I think we're running out of time.
Well, first of all, thanks a lot.